Hello there, another lesson on sequences, and now looking at what's called sigma notation. This is a Greek letter sigma, and this Greek letter sigma is actually a capital sigma. There's a lowercase sigma just to confuse us as well, which looks different. But this capital sigma, basically we use it to mean the sum of a variety of things. It could be a list, it could be calculate the sum of this lot, this list of numbers, or it could be that you have a formula, and that formula is then used to determine the list, if you like. So it could be the sum of sigma 4 plus 6 plus 8 or something like this, and just list these numbers. Or what is more common is, say this formula here, if you look at this, it goes up in twos and it's 2n plus 2. And you might say n equals 1 to 3, the first three terms. So I suppose this is less common. This is the one we usually see. So anyway, let's have a go. Series then is a posh name for a sequence where you add the terms. So 1, 4, 9, 16, 25 is a sequence, but 1 plus 4 plus 9 plus 16 plus 25, that sometimes is called a series. Personally, I don't care too much about the difference, other than I know that if they say series, I know they're meant to add them. So a sigma notation for a series, in this particular one, I've set my top number here to be 100, so it's all the square numbers, as you can see, up to 100. Hopefully you spotted they were the square numbers. And notice therefore I've written this as the sum, sigma, of the n squared from n equals 1 to 10. N, you always define what your variable is, and 10 up here is your top number. Notice it's 10 squared is where we're finishing, and we're starting at 1 squared over here. And that's why you always do a start number and an end number, top and bottom of the sigma. Starts at 1, last value n, and sigma then is this Greek capital. It's, I suppose, in the Greek alphabet is the equivalent of an S, and we use it therefore for a sum. So work out these, it says, the first three terms and the last term of the series given below. So all right, and so look, I suppose one thing I'd suggest here is we think of this as, well, let's actually write down what it is. Well, put 1 into this, you get 2 ones, or 2 minus 1 is 1, plus 2, well, this is the thing, you see, this is for n equals 1, and now we're doing n equals 2. So I'm not now thinking n equals 1, I'm thinking n equals 2. 2 2s are 4, minus 1 is 3, plus, now do n equals 3. 2 3s are 6, minus 1 is 5, plus, now do n equals 4. And after a while you start to realise, what's that, 2 4s are 8, minus 1 is 7. So this is a relatively simple sequence. It's 1 3 5 7. And could I work it out? Well, I suppose I could quite easily. I could carry it going, isn't it? I mean, it says it wants the first 20 terms. What would all that add up to? So I suppose you're just going to keep on going up to, what would the last number be? Well, the last number will be 2 20s minus 1. So when n is 20, it's equal to 39. So what did it want me to do anyway? Find the first three terms and the last term. There you go, I have actually done all of that and more. But actually what it adds up to, I haven't worked that out yet. I suppose I need to get to some point where I can work that out. Next one, what's this one? N equals 1. I'm going to do this the same way. N equals 1 gives me minus 3 to the 1. So minus 3 to the 1. To the 1 is just doesn't change the number, that's minus 3. Plus n is 2. Now that's minus 3 squared. Minus 3 squared. Notice on the calculator you type it in like this, but it equals 9. Then you do, since I've done it like that, I'll do this. This is minus 3 to the 3. And if you do that, you get minus 27. There's my first three terms then. It says the 100th term, n equals 100 now. So it's minus 3 to the 100. God knows what that is, no idea. I don't think your calculator will even be able to cope, so I'm going to write plus minus 3 to the 100. So what do the answers say? 135 and 30. I noticed the R plus is in the middle, like mine, and minus 3, 9. Yeah, there, that's right. Interestingly, this last one I just wrote as 3 to the 100 because every even term is actually positive. So you can just write that because minus 3 to 100 is the same as 3 to 100. So that's a better answer, I'd say. It's both right, but that's slightly better. So write the following using sigma notation. Well, it's the other way around, I suppose. What we're looking for here is an nth term for each sequence. If you get the nth term, you're halfway there. It's 2. Oh, it's just going up in 2s each time. So the 2 going up in 2s, I suppose, is 2n. So it's the sum of the 2n's, because 2n is 2, 4, 6, 8, 10, etc., etc. And I suppose what we need to do is write the first term. Well, 2 1s are 2, so that works. Goes up to 16. I think it finishes at 8. And on the next one, what's it doing? It's not going up in 2s. It's actually doubling each time, isn't it? You can see it's doubling. It's doubling. So I suppose a way to write this would be 2 times by something. Yeah, in fact, it's just, can I just do it 2 to the 1? This one's 2 squared. This one, yeah, that. So we can do just like that, and this then is 2 to the something. I think it's 2 to the 10. So this becomes the sum from n equals 1 to 10 of 2 to the n. Looks very similar, but they're very different. So what do the answers say? Yep, and yep, so it's exactly the same. So look, here's 4 for you to do. So just try to write out the first 3 terms and the last term of these 2 examples, and then the other way round, write these in sigma notation. So pause the video now. I'll do the same, but I'll pause the video and I'll come back and we'll go through them. Well, I hope you've done those. If you haven't, pause the video and do them. And what I want to do then is just make sure that we get the right answer. So again, if I was doing this, I'd put 1 in. That's 31. Oh, what am I about? That's the last term. Put 1 in, that's 4. Put 2 in, that's 7. Put 3 in, that's 10. And I think the last term is 31. So if I just do these here, 4, 7 and 10. And notice again the use of the pluses in between, because these are added. These are what I'm meant to be doing. And what's this one? N equals 1 to 10. So I've got to do minus 2. I'm just thinking to myself, what's this? It's minus 2 to the 1 minus 1. Oh, right. So it's minus 2 to the 0, really. Anything to the 0, of course, is equal to... I'm conscious that I'm thinking the answer is going to be there. So I think the first one will be a 1. Then I do minus 2 to the... Well, it's the second term, but I do got to take away 1 from it, so it's to the 1. I think that's minus 2. Then I do minus 2, and I think, well, you can see the pattern 0, 1, 2. The third term will be to the power 2. That's going to be 4. So it's going to be all these numbers added together. Next one will be, oh, what do I want the first 3 terms? What's the 10th term? Well, I suppose the 10th term will be minus 2 to the 10 minus 1, which will be 9. And minus 2 to the 9. I think it's, well, it's a negative 1, but for a start, notice because it's a negative number. This is 512, I think. So negative, yes. So this is minus 512 then, because it's negative. So what were the answers? Yeah, 1 minus 2 plus 4, maybe minus 8 presumably, and you just keep on going. But they don't want all of them, they just want the ones they said. Write these in sigma notation. Again, going for, they're trying to get the nth term. So what's going on here? You've got 1, 2, 5. I tell you what, 101, that's the one that makes me think, you know, hang on. This looks to me, this is like 100. But of course I've added 1 to it. It's like a square number, I think. And this is like 4 and I've added 1 to it. This is like 1 and this is a bit cheeky. This is 0. So this, I think, is like the square numbers. So it's the sum of the square numbers. But I've got to do n squared plus 1. But annoyingly, this one is n equals 0, which I then square. and then add 1. So I think this is one that I'm going to come on to later, where you can start instead at a different number to 1. It doesn't have to be 1 every time. So I started at 0 and going up to 10. Yeah, going up to 10, because this is 10 squared plus 1. Now there's probably another way of doing this. There's probably a way to, instead, whatever your value of n is, say your value of n is 1 here, well then you have to do 1 take away it and then square it. So it could be that you write this as n equals 1 of n take away 1 all squared, then probably add 1 as well. Because yeah, so that just gets a bit more complicated, and I probably have to go up to 11 there as well. I personally prefer this and just changing the start number. I don't know what the answer is of that. Yeah, that's the one there, and this presumably is that one multiplied out. And for what's this one? 5, 7 and 9, 11. Well, first of all, it goes up in 2s. Much nicer this. So it goes up in 2s. Well, I can just say 2n, but of course 2 times table is 2, 4, 6, so it's 2n plus 3. So really this is the sum of the 2n plus 3's, starting with n equal to 1. Yeah, that works. And how many would I need? I suppose here, what I'm really doing, I'm saying my 2n plus 3 will stop at 101. So that's 2n equals 98. And n therefore would be 49. So I think that's what's going on. I think there's 49 terms. That's a bit of a trick really, to work out how many terms you've got in your sequence. Let's see what the answer says. 2n plus 3 from 1 to 49. So what else is there? I mean, this is highlighting the fact they don't all start at 1. We saw that just now in that example. So this one here says find the sum of the 3n minus 2 from n equals 2 to 6. So let's just do this. N equals 2 to 6. So the first term will have 2 going into it. So when n is 2, it's 3 2's are 6, take away 2 is 4. If I put 3 into it, I'll get 7. If I put the next one into it, well, I've got to go 2, 3, I need 4 in, 5 in, and I need 6 in. So n is 4 will give me 10 plus 13 plus 16. So presumably it does say evaluate, so I've got to work these out. 11, 21, 34. I think that makes 50. I suppose we'll check in a bit. This one is exactly the same. Oh, look, weirdly, oh, horrible start number. We've got to start, and they've switched letters as well, just to confuse me even more. But it's the same. R is minus 3. I'm going to sub that in. I get 2 times, well, minus 3 squared is 9. So the first term is 18. Then I do r is minus 2. I go up 1. You always go up 1. So it's 2 times by minus 2 squared, which is 4. So that's 8. R is minus 1. So that's 2 times 1, which is 2. R is 0. That's 2 times nothing, which is nothing. And the last one is r equals 1, which is 2 times 1 squared, which is still 1, which is still 2 therefore. So 26. I think that makes 30. So I've done 2 so far. This one looks a bit horrible, doesn't it? We go I equals 2. So I put 2 into that. 2 take away 1 is 1. Square it is still 1. Times by p is 1p. Yeah. Don't know what p is. I equals 3. 3 taken away 1 is 2. Square root is 4. 4p. I equals 4. 4 taken 1 is 3. That's 9p then. And you can see the next one's going to be 16p when I is 5. Check it if you're not sure. So that's 10, 14, I reckon 30p. No idea if they're right. 50, 30 and 30p. Look, we've managed to squeeze this into a video, and we've done everything, and exercise 4b is what we'll practice in class. Cheers guys.